All right, in this video, I'll be solving the sample AP pre-calc questions that are given by the College Board in their course description. It's just posted on their website. And I'm going to begin solving the multiple choice portion. Okay, there's a no calculator portion and a calculator required portion. So I'm going to begin with the no calculator portion. All right, so let's dive right in. We're given this polynomial p, negative 4x to the fifth plus 3x squared plus 1. Which of the following statements about the end behavior of p is true? So does it go to negative or positive infinity as x approaches negative infinity? And similar, does p go to positive or negative infinity as x approaches to positive infinity? So this is a lot of other jargon that might help you, but we actually don't need to read all this. I previewed the questions, okay? We can directly find it ourselves, and then we can get the answer. So we want to take the limit as x approaches negative infinity of p of x, and we want to take the limit as x approaches positive infinity of p of x. Okay, so as x approaches either positive or negative infinity for polynomials as simple as this x to the fifth term will dominate. You can think of it as, well, as x gets bigger and bigger, like for example, a million, when x is a million to the fifth power is much bigger than a million squared. And obviously, a million is much to the fifth power is much bigger than 1. Okay, so as x keeps getting bigger, so even like a billion afterward, you can see that this term will dominate. These terms become very insignificant as x gets bigger and bigger. Okay, or bigger or smaller as x approaches negative infinity. Similar concept, okay? So we're gonna worry only about this biggest degree, okay? So as x approaches negative infinity, what would the sign be? Some huge negative number to the fifth power, is that negative or positive? That is negative, right? And then we have another negative from this negative 4, so it would approach positive infinity. And similarly, as x approaches infinity, so a huge positive number to the fifth power would be positive, right? And then we multiply it with negative 4, it will become negative. Okay, so let's look at which one matches what we found. So these are both the same direction. Okay, so it's probably one of these then. As x approaches negative infinity, it should approach positive infinity. So that looks like B then. Okay, so hopefully that makes sense. And then we can even look at the jargon that they give us. Sign of the leading term is negative. Degree of the leading term of P is odd. Therefore, this is exactly what we did, right? We're concerned with the first term because that's the biggest degree. Okay, and then we check the sign. That's exactly what we did. Okay, let's move on. Depth of water in feet at a certain place in a lake is modeled by a function w. The graph of y is w of t is shown for t is between 0 and 30, where t is the number of days since the first day of the month, where all intervals of t on which the depth of water is increasing at a decreasing rate. Okay, so if you remember, this should mean something, increasing at a decreasing rate. Okay, so first of all, we can just check because W is the depth, so we're interested in when the depth of water is increasing. So let's ignore that phrase first, at a decreasing rate. Let's ignore that phrase. So when is the depth of the water increasing? Obviously, it's increasing from 0 to 6, right? It's increasing, and then it decreases from 6 to 18, and then from 18 to 30, it increases again. So we can even like cross out everything here, right? Because over here it's decreasing, right? So anything between 6 and 18, we can eliminate. So like this one, because it includes 6 to 12, which is decreasing, right? All right, now let's worry about increasing at a decreasing rate. So if you don't remember anything about concavity, we can even just eyeball the graph. Is this increasing at an increasing rate? It is. If you look at the graph and think about it, right? Over here, it's still increasing, but it's slowing down, right? You can hopefully see that. So between 3 and 6, this matches the description, increasing at a decreasing rate, okay? How about over here? It's increasing, but it's actually increasing faster and faster, right? So the only interval that matches this description is from 3 to 6, so it's A. Okay, now if you remember, this sounds related to concavity. This means that it's increasing, because it says it's increasing, but concave, or we should say and concave down. Okay, when it's increasing but at a decreasing rate, it's concave down. So over here, it's increasing and concave down. Over here, from 0 to 3, it's increasing but concave up. So that doesn't match this, right? And over here, again, it's increasing but concave up. So that doesn't work either. Okay, so if you don't remember anything about concavity, you could just eyeball the graph and still get the right answer. But if you remember, this should sound like concavity. So it should be concave down, which is over there. Okay. Next, which of the following functions has a 0 at x is 3 and has a graph in the xy plane with a vertical asymptote at x is 2 and a hole at x is 1. Okay, so we can just brute force factor all of them. That might be the quickest way. So let's quickly factor each one. All right. So if we factor the top of this, it'll be what? X minus 3, x minus 1. And if we factor the bottom, it'll be x minus 2, x minus 1, correct? All right, now this one, well, the bottom is the same as here, right? The top, we would get what? X minus 3, x minus 2. All right, over here, let me write it over here, x minus 3 over this bottom, again, is the same as up there, so we can just copy that. Over here, x minus 3 is on top. What happens when you factor the bottom will be x minus 3, x minus 1. Okay, so we want there to be a 0 at x is 3. So this would satisfy it, this would satisfy it, this would satisfy it. Over here, there's a hole at x is 3, so not a 0, so we can eliminate D. Vertical asymptote at x is 2, so the denominator cannot equal to 2. That's all of them. Now, how about a hole at x is 1? So there should be x minus 1 on the top and the bottom. And the only one that satisfies that is this one, so the answer is A. Because the hole, they would cancel the x minus 1s, right? But it would not be in the domain still. Okay, polynomial function P is an odd function. This is probably key. Let's underline that. P of 3 equals negative 4 is a relative max of P, which is following statements about P of negative 3 must be true. Okay, so it asks what the value is and if it's a relative max or min. Okay, so if you remember what odd function is, f of negative x is negative f of x. Okay, so when we have P of 3 is negative 4, then using this definition, P of negative 3 should be negative of negative 4, which is positive 4. Okay, so we can eliminate B and D already. Okay, now is it a relative max or min? So graphically, if you remember for odd function, it's reflected about the origin. So when P of 3 is negative 4 is a relative max, so it'll look something like this over here, right? If this is 3, all right? Relative max, then at negative 3, if we reflect it about the origin, then it will be something like this. So it'll be a relative min then. So the answer is C. Okay. The graph of G is given by this guy, and the function H is given by this guy. Let K be the function given by K of X is H of X over G of X. What is the domain of K? All right, so let's just write out H of X divided by G of X. So K of X would be H of X is here. G of X is here. Okay, so let's factor the top and the bottom. So the top we would get what? X minus 7, x plus 5. The bottom we would get what? X minus 6, x plus 3 it looks like. Okay, so domain of K. So the domain, we know that we cannot divide by 0. Okay, so we can tell that x cannot equal to 6 or negative 3. There's no hole, so we're okay there. That would affect the domain also. The top, if x is 7, that'll just be 0. If x is negative 5, that's also 0. Okay, so don't get confused by that. So x cannot equal to 6 or negative 3. Otherwise, the value of x is fine because we won't be dividing by 0 then. So it should be, did I flip the 2? I don't see, oh, sorry. I'm missing an x here, okay? So it should be c. That's correct, okay? Okay, so one more time. Okay, let me do it over here. Okay, k of x. So we factor the top. Okay, so it should be a plus. So I can factor our x here first. So let me go slower. X squared minus 3x minus 18. Okay, so from here, let's go back to over here now. Okay, so first I factor our x on the bottom, and then this should get you x minus 6, x plus 3. All right, so x can equal to 6, negative 3, or 0. So the answer is C. So sorry for that mistake over there. I left that out. Okay, next, figure shown is the graph of a polynomial function g, which the following could be an expression for g. Okay, so we know that there's a 0 over here, here, and here, right? Let me even mark it. Okay. So there should be 1 that's negative and 2 that are positive. At least 2 that are positive, I should say. All right? And at least 1 that's negative. So there might be repeated zeros. Okay, so let's look at the choices to see if we can eliminate anything first, okay? Or maybe let me even say this. Over here, remember, when there's a even number of zeros, repeated zeros, then it will not cross the x-axis. When there's an odd number, it should cross the x-axis, like over here. But over here, it touches 0 and then it goes back up, right? It doesn't cross. So that means there's an even number of repeated zeros at this point. Okay, so for example, it could be like 2 or 4, something like that. Over here, it should be an odd number. Over here, it should be an odd number also. So odd includes 1. All right, so let's look at the choices. There should be a repeated 0 over here somewhere. All right, so the only choice would be C or D, where there's a repeated 0, right? Over here, there's just 1 of each. I'm not even looking at the positions yet, but there's only 1 of each, so it cannot satisfy that one of them is repeated. So we can eliminate A and B right away. Now, which one would it be over here? Well, for D, x would be negative 5, the 0. So that's over here, and that would be the repeated one, which is not the case, right? It has to be x 5 for the repeated 0 over here. Not over here, right? So the answer should be C just by that. Okay. Let me finish the problems on this page and I'll call it apart, all right? Table gives values for a polynomial function f as selected values of x. Let g of x equal a f of b of x plus c, where a, b, and c are positive. And the xy plane, the graph of g is constructed by applying 3 transformations to the graph of f in this order. Horizontal dilation by a factor of 2, vertical dilation by a factor of 3, vertical translation by 5. What is the value of g of negative 4? Okay, so we got to find these a, b, and c by what it tells us for the transformation, okay? So we can start easy. Hopefully you recognize vertical translation is the c. You add or subtract to shift vertically. Okay, and it tells us that A, B, and C are positive, so that makes our lives easier. So we know that C is equal to 5. All right, vertical dilation, or I learned it as stretching and compressing. I don't like the term dilation. All right, that's just a me issue. If you want to dilate it or stretch it by 3. So which term is it? Is it A or B? Vertical would be A. So A would equal to 3. All right, now here is the tricky part. Horizontal dilation by a factor of 2. All right, is B equal to 2 then? Remember, when we want to stretch it or dilate it, it's 1 over that factor, so it actually be half. Okay, If you don't remember this, you can think of, I just typically think of like, if we have sine of x versus sine of 2x, what happens? Sine 2x, you are compressing it, okay? Because we are decreasing the period, all right? Or increasing the frequency. Those are inversely related, if that sounds familiar. So when it's sine 2x, so for sine x, the period is 2 pi, but sine 2x, the period is pi. So within the original period of 2 pi, we have 2 cycles now. So we are compressing it. Versus if it's sine of half x, we're going to stretch it out, all right? So that's how I typically remember if I forget. So b is equal to half, all right? Don't put b equal to 2. That would get you the wrong answer. All right, so now let's plug in to this definition of g. So g of -4, because that's what we're finding. A is 3, so 3f of half times -4 plus 5. That's the definition of g, and x is -4. So that's what we want, right? So that's equal to 3f of -2 plus 5. What's f of -2? It's 5, right? This should equal to 20. Answer is D. Let k, w, z be positive constants, which the following is equivalent to log base 10 kz over w squared. We're just using properties of logs, okay? Remember, when we have a quotient of 2 items within the log, it's the difference. So it'll be log base 10 of kz minus log base 10 of w squared. Okay? That's the first step. Now, when we have a product, similarly, when there's a quotient, it's subtracting. When there's a product, it's the addition of the two. So it'd be log base 10k plus log base 10z. And then over here, remember when there's an exponent inside the log, we can pull it out. So it'd be minus 2 log base 10 of w. And that looks like b then, right? Okay, and the last problem for this part. Values of the terms in the geometric sequence g sub m are graphed in the figure, which the following is an expression for the nth term of the geometric series. So remember, geometric series is a common ratio. So what would the common ratio be here? It looks like it goes from 8 to 4, then 2, then to 1. So it looks like it's halving, right? So our common ratio is equal to half. That's probably important, okay? So we can eliminate b already because that's multiplying by 2 instead of multiplying by half. Okay, so now, which is it, A, C, or D? Well, we can even just plug in n is 1. Do we get 8? For example, over here, when we plug in n is equal to 1, we get, let me even write out, 4 times half to the 1 minus 2, which is -1, which is 4 times 2, which is 8. So that matches the first term, right? Over here, if n is equal to 1, once again, we should get 8. What happens when we plug in n as 1? We get 8 times half, which is equal to 4, which is not equal to 8, right? So it's not C. How about over here? It would be 16 times half to the, when n is 1, it would be to the 0 power, right? Which is 16, which is not equal to 8 again, so it cannot be D, because it doesn't match the first point over here. So the answer is A. Okay, hopefully this was helpful. I'll call it a part here, so please look out for the next video where I continue solving the remaining problems. Please like this video if it was helpful to you, and please subscribe also if you haven't already. I'll see you in the next video. Bye.